Hello everyone. This lecture will see some questions on number systems and try to solve them. Before moving forward, we'll see some divisibility rules. Certain numbers is the condition for numbers to be completely divisible by certain numbers. So here are some rules, uh, some conditions which are to be fulfilled if the number is to be completely divisible by the given numbers such as 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We won't be seeing divisibility rules for after 11 because they won't be needed in solving the questions. So let's proceed to the questions. The first question is, what is the smallest number that should be subtracted from 9805 so that it is divisible by 8? Here we can see for a number to be divisible by 8, with the last three digits are divisible by 8. So here the last three digits are 805. 805. So the smallest number that should be subtracted so that this number is completely divisible by 8. So we can see if the number becomes 800, it will be easily divisible by 8. So if we subtract 5 from this, we get 800, which will be divisible by 8. So the number that should be subtracted from this number is 5. Option 3. Moving on to the next question. The difference between the square of two odd consecutive integers is always divisible by which of these numbers? Uh, here we are. Here we have to find difference between the squares. So of two odd consecutive integers. Let's take first one integer, odd integer as 2x plus 1. Since 2x is always divisible by 2, adding 1 will always make it odd. After this, the next odd number will be 2x plus 3. We can see if number is 3, the next odd number will be 5. Next will be 7. So if this is 2x plus 1, this is 2x plus 3, this will be 2x plus 5. Taking any of these, we will take these two. It can be any number, not specifically 3, 5. So here we are asked squares of two consecutive. So square of this and square of this. Since we are asked to find the difference, we'll take bigger number first. 2x plus 3 whole square and minus 2x plus 1 whole square. Difference between two squares is always. Let's solve this. 4x square plus 6 to the 12x plus 9 minus 4x square plus 4x plus 1. Here we have simply used a plus b whole square, a square plus 2ab plus b square. Now 4x square plus 12x plus 9 minus, this minus multiplies inside, get minus 4x square minus 4x and minus 1. Here we get 4x square minus 4x square gets cancelled. 12x minus 4x, we have 8x plus 9 minus 1 minus 8. I mean plus 8. Taking 8 outside, taking 8 as common, we get x plus 1. So the number will be always divisible by 8. So the correct answer option becomes option number 4, 8. Moving to the next question. 7x plus 2 is a 3-digit number and x is the missing digit. If the number is divisible by 6, the missing digit is. So first we see uh, divisibility rule for 6 says a number is divisible by 6 if it is divisible by both 2 and 3. For a number to be divisible by both, uh, a number to be divisible by 2, the last digit needs to be even, and for the number to be divisible by 3, sum of digits needs to be divisible by 3. So the given number is 7x2. The last digit is even, so it is divisible by 4, divisible by 2, sorry, divisible by 2, one condition is fulfilled. Next we have to make it divisible by 3, divisible by 3. In order for the number to be divisible by 3, the sum should be divisible by 3. So 7 plus x plus 2 is equal to 9 plus x. 9 is already divisible by 3. So x should be a multiple of 3 or 0. Here the x could also be 0, but in the options we don't have 0. So the smallest number for x will be 3. Now the divisibility by 2 and 3 both conditions are satisfied, so number will be divisible by 6. Since the value of x comes out to be 3, the correct option would be option number 2. Moving on to the next question. Well students, you have to memorize all these divisibility rules. You will not be given these divisibility rules, you have to memorize them. So the next question we have here is a 3-digit number 4p3 is added to another 3-digit number. That's right, 4p3 is added to another 3-digit number 984. 984. Adding this we get 1, 3, 2, 7. Now we have to find the value of p plus q. Uh, Looking at this question, since here no carry has been added in these two, uh, since we are getting 9 plus 4 13, so no carry has been added, which means q is a single digit number and p is not greater than 1. If the value of p were to be 2, carry would have been added here, so the value would not be 9 4 13 would not be here. So from here we understand that p is less than 2, and from here we understand that q is less than 10 and greater than or equal to 8. The possible values of p from here, if we try to find, will be 0 and 1. Possible values of p are 0 and 1. Now we are said that the number is divisible by 11. This number is divisible by 11. So if we see the divisibility rules of 11, we see that the sum of digits of odd places and the difference between the sum of digits between even places is divisible by 11 or equal to 0. Uh, Here we have 1 plus q and 7 plus 3. 7 plus 3 minus 7 plus 3 minus 1 plus q. 10 minus 1 minus q. 10 minus 1 is 9. 9 minus q. 9 minus q is divisible by 11. So the condition for 9 minus q to be divisible by 11 is either it is divisible by 11 or equal to 0. So we from here we get q is equal to 9. Since q is here 9, uh, we have another equation here, p plus 8 is equal to q. We got the value of q from here. So p plus 8 is equal to 9. So the value of p comes out to be 1. So p plus q is equal to, the value of p is 1, q is 9, equals to 10. The correct answer comes out to be 10, which is option number 1. Moving on to the next question. The sum of first 49 natural numbers is, there is a formula for this. Sum of n natural numbers is equal to n by 2 1 plus n. So here we are given the value of n is 49. 49 by 2 to 49 plus 1. This will become 50. 2 1 ja 225. 25 into 49. 25 9 ja 225. Carry will be 22. 25 for the 100. Carry will be 22. 122. Here we see the correct answer is option number 3, 1225. Moving to the next question, we have given that 1 plus 2 plus up to 9 is equal to 45. Find the value of 11 plus 12 plus up to 19. There are two ways to solve this question. For sum of up to any arithmetic progression where the difference is equal, here we see that the difference between the terms is equal, which is equal to 1, 12 minus 11, 1, 13 minus 12, 1. This is known as common difference. If we have a series where the common difference is same, common difference denoted by D is same. Here for this case D is equal to 1. So the sum of n terms of such a series is n by 2 a plus l, where n is number of series, n is number of terms, number of terms, a is starting number of series, and L is the last term series. is starting number, or you can say first term. So using this formula, and we have from 11 to 19 we have 9 terms. 9 by 2, 11 plus 19. 11 plus 19 will be 9 by 2. 11 plus 19 comes 30. 2 1 ja 2 15, 15 9 ja 135. So the correct answer is option 3, 135. The second method to solve this is, we are given 1 plus 2 plus 3 plus up to 9 is 45, and we are asked to find 11 plus 12 plus 13 plus dot dot dot. This is second method. Up to 19. This series can be written as 10 plus 1 plus 10 plus 2 plus 10 plus 3 up to 10 plus 9. Now if we rearrange this series, we have 10 plus 10 plus 10 up to 9 times, and plus 1 plus 2 plus 3 up to 9. We have only rearranged the way of writing this. From above in the given, we have given the value of this is 45. 10 plus 10 plus 10 up to 9 times we get 90 plus 45. 90 plus 45 is 135, which is again the same. We have already found out above. There are two ways to solve this. The second way, you have to learn this because sometimes you have to break the series in such a format that you get previous series which is given in the question. Now moving on to the next question. If a number 653AB is divisible by 90, then the value of a plus b. We have to find the value of a plus b. 6, 5, 3, a, b. Now we know that this number is divisible by 90. Since the last digit here is 0 and these are divisible, so b must be 0. The value of b comes out to be 0. So cancelling out b and 0. Now this number 653a should be divisible by 9. So for the number to be divisible by 9, the sum of it should be divisible by 9. 6 plus 5 plus 3 plus a must be divisible by 9. 6 plus 5, 11 plus 3, 14 plus a. 14 plus a is divisible by 9, which is nearest number is 18. So the value of a will be 4. So a is equal to 4 and b is equal to 0. A plus b is equal to 4. So the correct option will be option number 3. Moving on to the next question, we have a number when multiplied by 16 increases by 540. Let the number be x. So when the number is multiplied by 16, x is multiplied by 16, the number increases by 540. Number x is increased by 540. So here we have 16x, transposing x to the left side, 16x minus x is equal to 540. 15x upon 540 dividing 540 by 15. 15 3s are 45. Here comes 9. So 15 6 are 90. 36. Answer will be 36. Moving on to the next question. What is the unit digit in the product of 863 multiplied by 1346 multiplied by 452 multiplied by 226? When you are asked a question like this, you have to multiply all the digits in the odd place, and whatever the number comes, the odd place of that number will be the answer, which means odd place of 3 into 6 to 2 into 6. We have 3 6 is 18, which means odd digit number in odd digit we have 8, then 2, 6 8 to the 16. The number in odd, the number in unit digit is 6 to 6. We have 36, so the number in unit digit is 6. 6 6 is 36, so the answer will be option number 2. Moving on to the next question. What is the number in unit place? Here the question is a bit misprinted. The actual question is 729 to the power 59. Whenever you are asked a question where you have to find the digit in unit place, you take the unit place and write its powers as 9 to the power 1. We have 9, 9 to the power 2, 81, 9 to the power 3, 729. When you see that the odd digits, unit digits are being repeated, when you see the unit digits are being repeated, you stop here. From here we can easily see when the power is odd, we have unit digit as 9. When the power is even, the unit digit is 1. When power is odd, unit digit is 9. When power is even, we have unit digit as 1. So here the power is odd digit. When the power is odd, unit digit is 9. So the answer would be option 1, 9. Since it was 9, we have only two numbers that come in odd place, 9 and 1. What to do when there is more than two numbers which come in unit place? Let's take another example of 132 to the power 43. Here if we write the series of powers of the number in unit digit, we have 2 to the power 1, 2 to the power 2 we get 4, 2 to the power 3 we get 8. 2 to the power 4 we get 16. 2 to the power 5 we have 32, which is again 2. So after 4 terms the series, the unit digit starts repeating itself. So the maximum number where after which the series starts repeating here is 4. So what we do, we take the power from here 43, 43 and divide it by 4. Whatever the remainder we get from here, here we will get 3. 4 times 40, the remainder. You put the remainder as power for the unit digit of the unit digit we are asked to find. 2 to the power 3. So the answer will be 8. Uh, that's it for now, guys. We'll meet each other in the next lecture.